This is our second lesson on our unit about circles, and today it's all about arcs and chords, and we're going to learn a couple new vocabulary words and then also some theorems. The first idea we're going to be talking about is the idea of a central angle, and it's an angle that starts at the vertex, at the center of the circle, and so this is an example of a central angle right here, okay? And its two sides are radii, and it has a vertex at the center. An arc is the unbroken part of the circle consisting of 2 points. So like this is an arc. And we could call this arc AB. And you'll notice we put a little arc symbol above it. So we're going to go learn some more now. So we have a minor arc whose central angle is less than 180. So you'll notice here that a minor arc, its central angle here is less than 180. Over here, this is a major arc, and it's greater than 180, or 360 minus the measure of that angle. And then we have the word semicircle, which means its central angle is exactly 180 degrees here. From here to here is 180, or half a circle. So let's move on and take a look here. Minor arcs can be named by 2 points, but major arcs and semicircles must be named by 3 points. So let's take a look at this. Let's get a nice vertex at the center. Let's call this A, B, and then let's call this C here. So if I go arc AB, it really means this arc right here. But if I'm trying to name this arc, which goes all the way around here, I have to use 3 letters, and I would call it arc ACB. All right, we're going to do a little problem here now, using some of these ideas and the idea of percents. So we're talking about different kinds of grass that are planted in the yards of people in a neighborhood. And our goal is to find the measure of the arc, KLF. So I'm going to go ahead and mark that in here. We're looking for this arc right here. So it shows us that it's 65%. So it's 65% of the whole circle. So if we know that the whole circle is 360 degrees here, we can take 360 times 65%. And go ahead and grab your calculators, and indeed we're going to multiply that out now and get 360 times 65 divided by 100, and that's 234 degrees. So the measure of major arc KLF is equal to 234 degrees. So that's how you do it. And if you wanted to find the measure of any of these other arcs, for example, of this one, it would be 20% of. So the measure of FG is equal to 20% of a whole circle. And indeed, we can multiply this out. This is a fifth, so this gets down to 36 over 5. Is that right? 360 over 5, sorry. And 360 over 5 goes about 70, oops, 72 degrees. So 20% would be 72 degrees. All right? Let's move on. Adjacent arcs are arcs that intersect in exactly one point. They're next door neighbors, as if you can think about them that way. The word adjacent often means next door neighbors. So the measure of an arc formed by 2 adjacent arcs is the sum. So the measure of this whole thing is actually the sum of this part and this part, which makes some sense, and we can go look at a problem right now. So we're looking for the measure of BD, okay? Measure of BD. Let's go figure this out. Well, you can see that AC is the diameter. So we can say that this part plus that part plus that one equals 180. So let's go ahead and call this here x. And we're going to go find x first by doing 97.4 plus 52 plus x equals 180. So let's go do that here on the calculator. 180 minus 97.5 plus 52. And you'll notice that I'm putting parentheses around that in the middle. And I get that x is 30.5. So we know x here is 30.5. We know BC also, because this angle is a vertical angle to that one, so it's 97.4. So the length of BD is actually made up of the measure of BC plus CD. And we know BC is 97.4, and we know CD is 30.5. So let's go ahead and add those two together, plus 97.4, and indeed we get 127.9 degrees. So the measure of the arc, BD, is the same as the measure of the central angle, which is 27.9 degrees. All right, we've got some more things here about congruent arcs. And it makes sense that congruent arcs on the circle will have congruent central angles. Okay? And they will also have congruent chords between them. So the chord UV is congruent to the chord here, ST. And let's go look at some problems involving those ideas after you've read through that. Feel free to pause here, make some notes, but I am going to go through this quickly. Because these two chords are congruent here, it means that the two central angles are congruent, that those two angles, this angle and that angle, are congruent. Therefore, I can set the two arcs equal to each other. So I've got 9n minus 11 equals 7n plus 11. And here we bring this over, 2n equals 22, n equals 11. And they want us to find the measure of the arc WS. WS, and indeed that's going to be 7, 11 plus 11, like this. And it's going to be 77 plus 11 is 88 degrees. So that's an example of the type of problem that we would do using some of these new theorems. All right, we have two more theorems here, which talk about chords and radii being perpendicular. So if I have a chord and a radius that's perpendicular, it's going to bisect that chord, meaning that these two parts are going to be congruent to each other. And we're going to show you some examples of that. And this is just the converse. Okay? If I have a diameter here that is perpendicular, sorry, one more time. If I have a chord JK that is the bisector of GH, okay, then it is the diameter. In a circle, the perpendicular bisector of a chord is a radius or diameter. All right, read these through, go ahead and draw them, and we'll continue on here. So find NP. So here we have, and let's go ahead and add some things to this picture here. We know this segment here is 8, and that's 9. The total length of the radius then is what length? If this part's 8 and that part's 9, it's 17. Okay? So we want to find NP. But what we're going to do first is we're going to find NS, and then we'll double it. So let me show you what we've got here. We've got a right triangle. That's 8, that's 17, and that's a right angle because of that theorem we just learned. Let's call this X, which is this distant x right here from here to here. Of course, we're going to go use Mr. Pythagoras. 8 squared plus x squared equals 17 squared. So let's go do 17 squared minus 8 squared. And indeed, that's 225, which means x is equal to the square root of that, which is 15. So if x is 15, 2x is equal to 30. So, and the length of NP is equal to 30. So we've learned a lot today. We've learned about the chords and the arcs. Go through all of these theorems again. Make sure you write them nicely into your notes. But that's what we'll be doing in class. Thanks.